Hello, welcome to the third video on Microsoft Excel. Today we are going to go over some of the examples that are provided in the Winston text for Chapter 1. As you can see, I have the file folder open here. I've labeled all of the files for this tutorial as starting with the 1, and then the next video will start with the 2, and so on. The first file we're going to look at is the wage file. So I'll open it here. So very simple table, just like last time, the one I created for the PC parts inventory that I did. In this case, though, we're looking at wages. We want to find out how much money we pay each of our employees for our company, and then the total of that. So the question from the text is, how can I efficiently determine each of my employees' weekly wage? Well, just like in the PC parts example, when I was adding the cost of the parts times the number of parts, in this example, we're multiplying the hourly wage by the number of hours that each employee works. So we need to put a formula in right here in this third column where it says weekly salary. So like before, we press equals, right? And we're going to multiply the hours times the wage. So this first employee makes $490 per week. I'm going to grab the corner and drag it down. Now I have a total per week for each employee. And here I could use the auto sum by clicking the auto sum button and add up the total wages for the week. Right? That's how much I pay everybody for the whole week. But what the question here is, and the formula that we need to write this time is not the sum, but rather the average. What is the average amount that employees make per week? So we're going to change the sum function to the average function, AVG. Just like that, and leave the same range. Excel found that I had a typo in my formula and automatically fixed it for me, right? It wanted me to spell out the word average instead of just AVG. So that is the average amount that employees make per week in my company. Once again, I'll just delete that real quick. I can write it from scratch, equals AV, and you'll see it gives me the drop-down list of all of the functions or formulas that start with AV. I can just scroll down to average, hit enter, right? It's giving me this error because I didn't specify, sorry, it didn't even work. Double click on that, there we go. So average is inserted in there for me. It gives me the syntax that I need to follow. In this case, I'm going to click on the first one, hold shift, and click on the last cell in the range, and it gives me the range. Press enter. All right, that's a little trick for you. All right, if you want to create a range while you're entering the data entering the values into the formula, I can use the shift key. Once again, equals average. I can type in, E4, so E4 to E11. I can type it in like that if I know my range. Or I can use my mouse, click on the first cell in the range, hold down shift, click on the last cell in the range, and you'll see that it inserted the range. Hit enter. I could even, by using the control key, I can even select individual cells like this, and it will put the commas in between each cell value, like so, if I don't want to average everybody's salary. Here to here. And so we have our solution to the question. We have determined how much each employee makes per week, and we have the average salary of employees for the week. So go ahead and close that. I'm not going to save it. The next one we're going to look at is, let's look at the bakery. this example, the question that's being asked is how can I efficiently determine how much a bakery owes each supplier? So, bakeries have to buy ingredients for their goods. In this case, it's sugar, butter, and flour. We have different suppliers that provide those ingredients to us at different prices. So supplier 1 sells us sugar at 32 cents a pound, butter at $1.57 a pound, and flour at 11 cents a pound. Right? The next table, we have the quantity. So we ordered 364 pounds of sugar from supplier 1, 387 from supplier 2, and so on. So what is the total amount that we spent on sugar for supplier 1? So we will type a formula. Once again, press equals. We take the price times the quantity. Right? This is the amount of sugar. This is the cost of the sugar that we purchased from supplier 1. Now we can click on the little box in the corner, drag it across. Oops, a little too far there. And we have how much we paid to supplier 1 or in this case, how much we owe to supplier 1 in sugar, butter, and flour. I'm going to delete these real quick and show you. I can grab that little corner and I can actually split it over the complete range like that. Well, I thought I could, maybe not. So across, but I should be able to pull all these down at the same time. Yeah, there we go. So now we have our table filled in with the amounts that we owe for each supplier. At the bottom, we can total how much we owe for sugar, butter, and flour for all the suppliers combined. We're just going to use the auto sum key. It's going to select the range for us, hit enter. And now we know how much we owe for sugar total. Drag it across, butter, and flour. We can see that we spend a lot more money on butter than sugar or flour. We can also total how much we owe each supplier for all 3 ingredients on the right. Once again, auto sum. It looks to the left of the cell, finds the values, and automatically enters our range. We pull this down, and we get a total for each supplier. This is how much money we need to pay each supplier for everything that we've received from them. This is how much we paid for each ingredient from all suppliers. And then right here we could have a kind of grand total where how much we paid for all the ingredients from all the suppliers total. Just pull this over and you see we're getting these numbers here. Excel does this when the value is too large to display within the cell. So we need to make the column wider so we can see the whole value because we've gone into 6 digits there, right? Good. So that's the total right there for the whole shebang. All right, let's look at the next example from chapter 1. I'm going to close this. I'm not going to save it. The next example is, I think we want to look at customers. So in this example, we're being asked the question, how can we predict the number of customers a health club will have in 10 years? Basically, this is a simple forecasting problem. We'll talk a lot more about forecasting later, but just to give you an introduction to it, we want to try to figure out how many customers we can expect. What we start with are 3 values is the starting number, the number we expect every year, right? And the churn rate. Churn rate meaning the quit. What percentage of customers quit every year? I need to delete these. All right. So the starting customer equals, just like it says here, start, right? We start with 100 customers. Okay. New customers is always equal to this. It's 20, right? But it's going to be 20. And the number that quit is 15%. So this is a formula. This equals the total of these two columns, 100 plus 20 times the loss, right? How many customers quit? Actually, I'm sorry. Let me do this differently. This is just the quit, so it's just the start customers times the churn rate. So this is just the number of customers that will quit. Sorry about that. The end customers is going to be the number that quit subtracted from the total of the new customers and the start customers, which is what I was trying to do a second ago. This equals start customers plus the new customers minus the number of customers that quit. And enter. And the total end customers is 105. Now the end amount for the previous year is the start amount for the next year. So the start for year 2 is going to be the end of year 1, right? The new customers is the same. It's always 20. So I can just drag that formula down. But there's a problem. What happened there was that instead of this cell formula refers to this value, which is C3, but when I drag it down, Excel automatically adjusts the row. So it's actually referring to C4 when it should be C3. So that's a mistake. I need to delete that. Either I can type equals C3 again, right? Like that. I can do that. But the better way to do this, because we want our table to be dynamic, we want it to change. If we change this value, we want it to change as well, is that we want to fix the row number so that it doesn't change. And we do that by putting a $ in front of the row number. This makes it absolute or fixed. So now when I pull that down, it's going to stay in that row. So I did that all the way down because I know this is not going to change. Similarly, our formula here is the start customers times 50% to get the quit rate. If I pull this down, it's going to be an issue because it's going to adjust the row and it's going to give me a 0. So I need to do the same thing. I need to put the $ in front of the number there so that it stays fixed on C4. Right? I can also put it in front of C if I wanted to as well to fix the column if I felt that was needed. So pull it down now and just see it gives me a number, right? Nothing zeros here yet because I don't have the start number yet. This one I can just pull down all the way simply because I want it to adjust the rows for each one. Or do I? Yeah, that's right. And so what I'm missing now is the start number. The start number always equals the previous end number, so I just pull this down. Should be fine. And now my table is complete. Now there's a lot of decimal points in here because we're doing multiplication and division. So what I'm going to do is highlight the whole table, and I'm going to take out these decimal points. Oops, I'm putting them in. So let's take them out. Make it nice, even numbers. I want my column lifts to be the same. Way too big. Like so, nice and clean. So there's my completed table. I can predict the number of customers I'll have at the end of 10 years based on my loss and on my gains. Just basically a rolling forecast from year to year. So after 10 years, I would expect to have 127 customers when I started at 100, right? About a 30% growth rate. Right? Next problem. Close that. to save it. Actually, I'm going to save this because I want to fix this. Save that and close it. So the last one here is the coffee shop. A little bit more complicated. The question is, how can my local coffee shop determine how changes in price and unit costs affect profit? So the coffee shop wants to know how to maximize its profit. This is a sort of utility question that we're answering here using an Excel table. The two values that we're given is the demand slope and the demand intercept, or basically the average demand for a cup of coffee every day, multiplied by 15 or minus 15 times the price. This is a very simple equation. What it means is that as the price goes up, we expect the demand to go down, right? So as the price goes up, the demand goes down. So we're looking for that sweet point at which we can charge the maximum for a cup of coffee and make the greatest profit. We don't want to charge too much or too little for that cup of coffee. And what we have to consider in the profit on a cup of coffee is what we sell it for minus what it costs us to make that cup of coffee. So because the formula is a bit complicated, I went ahead and wrote the formula in advance here, right? And just to explain it to you, you see the dollar signs? That means it's just fixed. It means we don't want these values to change. We want them always to stay. And so F5 is the demand, and F4 is the demand slope. Two variables we're working with. We put these in parentheses because in formulas, the Excel always moves from left to right, but it also always calculates what's in parentheses first. So it will do this equation first, then multiply it by this equation. As opposed, if I were to take off this parenthesis, then it would be multiplying F9 by this number. We don't want that. We want it to multiply the end result of this formula by the end result or solution of this formula, right? So it's F5 minus F4, that is the demand minus demand slope, times the price. So as the price increases, this demand is going to go down. As it decreases, demand is going to go up. And then we subtract the actual price minus the cost, which is the profit. Okay, that's just the profit right there. All right. So I put that formula here. You can see if we sell the coffee at $2 and it costs 50 cents, then we make $105 off 100 cups of coffee, about, right? Not exactly, but around there. So at 50 cents cost, we make the greatest profit by selling it at $3.50. That's $142 by selling it at $3.50. I've just taken this formula and dragged it across. All it does is add in the different price in each formula. The only value that's actually changing, is the price. Price right here, G9, the price, because the cost is staying steady at 50 cents. Right? Now, when I bring that formula down, then the cost is going to change, and the price is going to stay the same for this column. I spread it across, so then for this cost at each of these prices, it tells us how much profit we're going to make, right? And when we make this change, we find that as the costs went up, we needed to raise the price, and the maximum that we could make would be $120. We can go ahead and finish off the table, right? And now we see, and it's highlighted in yellow, the maximum value for each row, the classic utility table. So at $3.50, right, that would be the best price to charge at 50% cost, 50-cent cost. At $1 cost, it's better to charge a little bit more, $4 a cup. At $2 cost, it's best to charge $4.50 a cup, which makes sense, right? Our sell price went up by 50 cents because our cost price went up by 50 cents. So it's basically like passing the extra cost on to the customer to maintain the maximum amount of profit. But we did lose profit because of the price, because of the cost increase. That's a good way for a coffee shop to determine what to charge for their coffee. That's pretty much explains that example. Just give you just a taste of forecasting, which we'll be digging into much deeper later on in the semester. This yellow formatting is conditional formatting. We'll talk about this later too. I'll show you how to do this, but this just gives you a little hint of what's coming later. Conditional formatting is up here on the ribbon. It's just basically Excel auto-highlighting the best value out of all the values within this row automatically for us. All right. Okay, I think that concludes. Oh, actually, there's one more. Sorry, one more. That concludes all the examples, but there's one more spreadsheet to look at. Let me close this. I'm not going to save it. So the final spreadsheet I have in the folder here is called Practice. And Practice combines all of the examples that I just gave you into one you might call it a very simple DSS, right? That a bakery might need. So this is based around the bakery. So this is just for your practice. What I'd like you to do now is just after you've gone through these examples and understand them, to apply what you've learned to this practice sheet. This is just like before, except in this case the value is a little different. But we consider that these to be the employees at the bakery and how much they make. So we can get an idea of what our HR personnel costs are for the bakery. In this example, we want to know how much it costs to make each product, just like we did in the coffee example. Suppliers is pretty much the same as before. It's almost identical to before. The next tab here is suppliers if they had fixed costs, but not different costs for each supplier, but the same costs for each supplier. And then customers, just like in the earlier one that we did for the gym, this would be estimating the customers for the bakery. And with all these different tabs, you see at the bottom here, I'm clicking on these tabs. An Excel sheet is made up of multiple tabs. And you can add as many tabs as you want by clicking on the new sheet, little plus button, you get a new sheet. Double click in there and you can change the name of the sheet to whatever you want. You can also move the sheets around by holding and dragging the sheets like this if you want to reorder them. All right. So just as a practice, go through each of these tabs, solve the problem for each tab, basically fill in the blanks, and then you have a pretty good basic understanding of the first, simple formulas in Excel and how to enter formulas. In the next video, we'll get into some tips and tricks for Excel, and from there we'll move into some more advanced formulas and how to write to more complicated, how to create more complicated spreadsheets. Okay, thanks, bye.